The build that we're doing today is the SlimPhast 4-inch from RC Crazed. We're going to use the Runcam Micro camera. I use this on almost every build now because it's just as good as every other camera. It weighs much less, and the quality is just on point, so why even bother with a bigger camera? We're using the TBS Unify Pro Race, and then got these motors, and that's going to be the Hyperlite 1407 3600 kV motor. So that's what we're going to be using. I've had these on my Phast 4-inch, and I really like the way that it flew, so I'm going to put them on this one as well. For the flight controller and the ESC, I just got these in from Airbot, and that is the flight controller is going to be the Omnibus F4 Nano V3 because this frame takes a 20x20 hole pattern size. So we're going to be using the Omnibus Nano. That's the V4, and then we pair that with the Ori 32 4-in-1. So that's a 25 amp 4-in-1 with the 20x20 hole pattern. So that's a pretty beastly, and that's 32-bit. It's a pretty beastly ESC in a very small footprint. And then I've got the little wire harness as well, so that's going to make the build really clean. You know, once we get the ESC wired up to the motors, it's just one cable. It's going to bridge it to the flight controller. It's going to be a pretty easy build. It's going to look really clean, I think. So that is the plan. Let's see what's in the package. One thing I love about the RC Crazed frames is that they come with all of the 3D printed parts you'd expect. So we've got a camera, like a camera hood protector, the back plate for the antenna and the SMA for your both your receiver and your video antennas, and then we have the little Runcam Micro protector that actually mounts it to the front standoffs. So they always send you awesome 3D printed parts of their frames, and it makes your build go really easy. There's not a lot you have to figure out yourself. It's already kind of figured out for you, and you just have to put it together. Got our hardware, standoffs, and just the bolts. The awesome battery strap with a really sticky grip on it. And what do we have? We've got, looks like 5 arms, the main plate, and our top plate. You can see the size difference between the 5-inch and the 4-inch arm. So we've got the silver standoffs, and the different bolts we have are the 16mm, the 12mm, and the 6mm screws. And the placement of those all matters, so we're going to make sure we get them in the right spots. Alright, so we're going to take the main plate here, we're going to take the medium-sized screw and put it in the outside hole. We're going to put the arm on, and that little curve spot on the arm here, it's going to go on the inside. So not like that, but like so. And then we're going to end up using the big nut here, not the small nut. I'm just going to kind of lightly screw that in. And now we're going to take the largest screw and put that in the other hole, which is on the inside of the frame. And then we're going to use the smaller nut. And you can see on the bottom arm, that little cutout on the frame aligns with the cutout on the arm, so you know you're getting them the right way. Alright, so that is how she'll look. So I'm going to go ahead and tighten all those down. Alright, I'm lazy, so I like to get mine mostly tightened down with a power drill. But I've got it set on a setting to where it's not torquing them down, so I'm not going to strip out the heads on these screws. Now that we got those started, finish it up with just a hand tool here. Alright, got all those down. So the way this is going to work is our knurled silver standoffs will screw in right over top of that, and that's what our top plate's going to mount to. But we're not going to do that yet because we've got to get the stack and the motors all put on. Got that on. Let's grab our 4-in-1. So again, this is the Airbot Ori 32 4-in-1 ESC 4x28 25 amp, which will be more than enough for the motors and props that I will be using. That's going to mount right in there. That is tight. but I think it will work. So I'm going to feed one through, and then match that to an M3 nylon standoff. And I found that over tightening these screws here, what will happen is when in a hard crash, you'll actually split the nylon standoffs, and you'll have your flight controller stack just kind of floating in the middle. So I wouldn't over tighten those. You're gonna typically I put a magic gel pad or piece of Velcro on the bottom, and it holds those screws in anyway, so those aren't going anywhere. So I would just not over tighten those. And I'm going to look around and make sure I'm not bumping into anything, so I can see. I want to make sure that the arm here doesn't make contact with any of the parts on the bottom of this board. Even if it doesn't look like it's pressing on it hard, it could be making connections that we don't want, or just cause other problems like that. So I can tell that there's good clearance between all the parts of the frame and the 4-in-1. So obviously the front of the frame is here, where you have this guard to protect your camera, and in the back you have 2 slots here where you can zip tie down your power cable. All the solder points are on the top of the board, so we don't need to mess with any of that. We can simply mount it and solder all over everything to the top and move on from there. I always soft mount my flight controllers anymore, so on top of these nylon, hard standoffs, I'm going to be using these Maytag Systems rubber dampeners. So those thread right on top of there, and my flight controller will sit on top of that, and there's a lot of play in this, so typically the bad vibrations, if they do occur in a motor or from a vent prop, they don't make their way into the flight controller. These do have like a really narrow seat on the bottom side, so I typically will have to trim down the heads of these standoffs a little bit.
Alright, so here's my general process for soldering the motor wires onto the 4-in-1 ESC. First thing I'm going to do is tin every pad we're going to use on the 4-in-1. Then I'm going to start with one motor. I'm going to position the wires along the path they plan to run. Take note of any standoffs that'll be in your way on the final build. It's a real pain in the ass when you go to put your top plate on and realize your wires aren't long enough to route around a standoff or a side plate. You want to cut the wires to length, strip them back 1/4 of an inch, and tin them all with solder. Now I hold the wire over the pad where I'm going to solder down, and then I use the iron to press that wire into the pad. Both the solder on the wire and the pad should go liquid and make a nice connection. Remove the iron, but keep holding the wire in place until you see it harden.
Alright, so we've got our motor wires all connected to the 4-in-1 ESC. We've got our battery hooked up. I've gone ahead and hooked up the wire harness. So at this point, we can put on the flight controller. So that is going to go on the standoffs. I think I'm going to do it like that with the USB out the back, so that this wire harness can just bend straight up and connect in without having to go all over the place. And this guy will mount just like that, and that will be our stack. We've got the 4-in-1 ESC on the bottom, Omnibus F4 Nano on top.
Okay, here's exactly what we have wired up. We've got our battery and our motors hooked up to the 4-in-1. I only drew the motor wires in for one motor, but you get the idea. The first time I'm wiring up a new flight controller, I like to do what I call a dry run, where I keep all the wires extra long. I'm not going for that really fine finish. I'm just trying to get everything soldered to the flight controller so I can test that the quad arms and the motors all spin and the video works and my smart audio works and my smart port telemetry works. Like, there's a lot of stuff going on there, and it sucks when you cut a wire to go to, say, TX1 and realize, shit, that needs to go to TX4, and now your wire's not long enough to get there. So that's what I'm doing right now. Alright, you can see how I've wired the power, ground, and S-bus out right to the board. They're all 3 pins in a row. It's pretty nice. I also added the uninverted smart port to the TX1 spot, hoping I could get smart port telemetry to work. It didn't actually work in that spot, so I'm going to figure that out later, so you can skip that wire altogether. Alright, next we're wiring up the VTX. I've run the power and ground straight to the battery pads on the 4-in-1. There are pads on the flight controller for power and ground, but I don't like to power my VTX off of that just because of the amp draw. And then I've run the audio cable to TX6. That's going to be used for smart audio. And then I use the video straight to V out on the flight controller, which is the yellow wire.
So that means we're basically going to just rip out our 5-volt out. Let's pull that right out. We're going to find our other ground because it shares a pin with the other ground wire, I'm just gonna cut it, kind of pull on it a little bit so that the wire's pulled inside of the insulator, and then I'm gonna cut this guy off. We're gonna run the video to our video out, which is labeled as V out. It's the third one in here. Alright, and then we're gonna take our audio wire. This is our smart audio that we're gonna use. And I'm gonna wire that up to TX6. Alright, the camera's super easy. We're gonna wire up the power to the what's labeled CAM. I think that's really supposed to stand for RAM, which is either battery power or 5-volt out, depending on what you have the jumper set to. Then we're gonna run the ground to the ground next to that, and then we're gonna run the video to the video in. Always, always, always before I first plug in the battery, I like to do a quick continuity check. Just make sure I don't have a short that's obvious and it's gonna cause a bunch of issues, so we're good there. So I need to actually get an antenna on this or I'll burn up that VTX. Alright, at this point I make sure that I'm getting video out and I can see my OSD and all that works. Now I'm ready to resolder and cut all the wires to the perfect length and really clean up the board and then button up the top. Okay, so once I get the camera on there, I can see that I have a lot of extra wire, and I don't like to have any extra wire, so I'm basically going to be trimming all that back. If I know that I'm working with a set of cables that has a plug on it, like the camera plug, then I don't worry about making them super short, because I know that I can always just pull that plug out if I need to move things around or get in there. If it was the soldering wire between an ESC or the 4-in-1 and the board, I might provide myself some extra room so that way I can pop the top off and get in and out, but with the cable, might as well just cut it short. I really like this camera mount. They've beefed up the amount of protection in the front here from the old version that I had. I really like the way that looks too. If you're not great at soldering, I wouldn't solder over top of your board like I just did. Feed too much solder in, you might get splatter and it'll land on the board and could cause you some issues. I normally would just pull this extra stuff off. Like I know I'm not going to be using this voltage wire. I'm just going to pull that out, and I might leave this on for tuning my for tuning the camera settings. So right now I'm just going to kind of push that up out of the way and leave it alone. Again, I just love the 3D printed parts that come with the RC Crazed frames. It just makes it so much easier. You don't have to figure this stuff out. It's already been figured out for you. Alright, so to do a retrospective on this build, I definitely, if I were to redo it, I would do it differently. The F4 flight controller that I chose, the Omnibus F4 Nano V3, sticks out past the holes, like probably like 3 millimeters on each side. And what happens is, because of that, on the front side, my camera plug ends up hitting that board. So I'm kind of capped at about 45 degrees. And I actually end up having to use a different set of 3D printed camera mounts because the ones that came with it were a little bit shorter, and it had the camera set back a little bit, and it was running into the front of that flight controller. I think if I were to redo this, I would turn both the flight controller and the 4-in-1 stack, because they're connected with a tiny ribbon. I would turn that on its side. Unfortunately, if I did that, I'd have the battery wires coming out the side. I don't normally like to do that, but it would be better. Also, I don't know if you can see, so I've got my USB coming out the back, and there's some power wires right there that are exposed, sticking out the back of the frame. So I'm gonna have to be careful when I'm plugging in my USB. If I'm using USB and battery power at the same time to, say, program my ESCs, that could be an issue. So that's something I need to watch out for. So I've ended up zip tying the VTX to the RSXR, and those are kind of just floating here on top. Once you put the top plate on and it puts a little bit of pressure on it, it holds that in place so it's not wiggling around. It's not going to come out. I also was not able to use the normal rubber standoffs that I'd use here for the flight controller stack. Normally I would do nylon on the bottom, 4-in-1, and then the rubber, these guys, the rubber standoffs for vibration isolation, flight controller stack, and then nylon standoffs, or nylon nut on top. But I've ended up just going nylon, rubber, a little grommet thing, and then a nylon standoff on top. So I should still get some vibration isolation, but not anywhere near as good as if I was using this guy. The reason I had to do that was because with the taller standoff, it raised the board high enough that it was hitting the camera plug, that I was only able to get like maybe 35-40 degrees of tilt. And with a build this light, you really need to have a lot of tilt to be in control, in my opinion.
So comparing these two boards, the one on the left is the Omnibus F4 Nano V4, and the one on the right is the V3. You can see the V4 sticks out quite a bit further off the standoff holes. So if you're going to use it on this build, I would suggest turning it on its side and having the USB come out the side. Or just go with the V3. I think it's going to work out a lot better for you. You can see that you can then run your cable out the front to the 4-in-1 and have the USB still coming out the side so they aren't stacked, and you don't have the USB stacked over top of your power connectors.
I also ditched the SMA. I did have the normal cable for the VTX that has the SMA on it. You can see that if I screwed an SMA in to this, there would not be any room for that to stick forward. So this screws in to there, and this the bottom part of the SMA cable was just jamming into the back of the flight controller, and there just wasn't any room for that. RC Crazed has a back antenna mount that is 90 degrees. If I went with a 90-degree mount, I could probably get this to go in there and then just bend my antenna down below the prop line. But I ended up just going with the Pigtail Furious FPV antenna because I've used these before and they work great and they're lightweight, and I think it would work well with this build. I'm going to add probably one zip tie that holds it to the mount through one of the lobes, and that makes sure that it doesn't come back a little bit and end up getting into the props, which happens, but it ends up just getting knocked out of the way anyway, so it's not a huge deal. I normally will pull the antenna out a little bit, put a dab of hot glue on there, and then push it back in, and that keeps the antenna from getting out too far and getting bent on the end, or falling out, into the frame, and then I'm not getting the penetration outside the carbon fiber that I need for a good radio connection. But overall, I'm pretty happy with it. I'm going to get it all buttoned up and then get it outside and test fly it. Alright, the final weight is 186 grams. That's what she looks like. Alright, let's get outside and fly it.